Welcome to another lecture in computing technology. Let's just head over to the schedule and let's have a look at where we are and where we've been and where we're going. Well, covered a lot of ground. Last week was a change from the first several weeks of C. Of course, we started from looking at Scratch. All along, we've been building conceptual tools about algorithms, data structures, how to create functions, how to make computers do work for us. And we've been taking a trip through several languages, conceptually and visually in Scratch, and then the grandfather of modern programming languages, C. And then last week we introduced Python. I hope a lot of you found that Python was easier and created shorter, even more readable code. And we're just scratching the surface for all the neat tools that we can use to increase our efficiency when we're programming in Python. And today we're going to stay with Python for just a little bit, just at the beginning, but introduce one of the real workhorse programming languages called SQL or SQL. And then we're going to move on a little bit about that after that and talk about some tools to really solve problems with web apps after that. Most people will stick with Python for the workhorse programming language, not just for the rest of this module, but onward and upwards in your careers. At least a lot of you will. Okay, so today we're on Lecture 8. You can follow along with the slides if you wish, and of course you're responsible for the notes. I highly recommend running the code as well, and there are just a few tutorials this week. All right, so we're going to look at the notes here. All right, so what we're talking about this week is SQL, but we're going to start with a few basic concepts about data and reading data in to memory with programming tools that we're going to do work on. And before we introduce the concept of the modern concept of a database, we're going to talk about what some people call a flat file database. Okay, and this is just a data set like some of us are used to working with all the time that might be represented in an Excel spreadsheet. And a real common format for that is the comma-separated values file format, or the CSV. And now we're going to start with some of the functions using the CSV library in Python. And to check that out, and I highly recommend you do in the notes as usual, you're going to want to check out the code in the file's favorites. And just like normal, there are a number of them where we build up concepts for handling and manipulating CSV files. And so to explore this, you want to check this out in the code and in the notes. And that's basically what we're doing. I'm going to leave that up to you to check out as usual. And before too long, you'll figure out that that a lot of the functionality in Python that makes it super fast, that really improves the efficiency, has to do with a dictionary data structure. And so favorites versions 5 through 8 deal with this dictionary data structure and how that's implemented for CSV functions in Python. So you can read about that. I highly recommend running the code and doing other things. Now, these flat file databases are really useful. They're very common. I use them almost every day doing statistical analyses and other kinds of analyses. But really, if you have more complicated data, especially if you have bigger data, we want to start using something called a relational database. And we'll unpack what that means, but it essentially is a data structure that stores data, usually designed to store lots of data, and it's where individual variables within the database relate to each other in specific ways. And we'll go through plenty of examples for that. So we come up with this lexicon of jargon around databases, and one of them is to describe the database themselves. And we refer to all modern databases, virtually all the biggest ones, fastest ones, big data ones, are some form of relational database. And the most popular language to manipulate and do work with relational databases is SQL. Some people call it SQL, some people call it SQL. SQL stands for Structured Query Language. Now, how do we actually work with the data? Well, we're going to practice this in the lecture today. We're going to talk about it in lecture and practice it in the notes and implement it in the tutorials. But essentially, we have this acronym CRUD. And what the heck does CRUD stand for? Well, CRUD is a database-specific piece of jargon that everybody that works with SQL knows, and it stands for create, read, update, delete. And these are the four primary actions we can take with a database. We can create it, we can read the data from it, we can update the data in it, and we can delete the data from it. Okay. And now the terminology, the actual syntax to perform these operations is exactly like you read them, with one exception, and that's the read one. And in SQL, we use the select command to read data, and we'll practice this a lot. But the others are all exactly the same. And, you know, there are some variations, like, for example, we can use a special command to just insert some data after a database is created, but it creates new lines of data. And likewise, the analog to insert, where we're not destroying a whole database, is to drop some lines that we select. And, you know, there are quite a lot more. But these are the basic ones that you'll be using all the time. And now we want to think of a table in SQL as some representation like a spreadsheet. And here the create command means we're going to make something new. The table command means that thing we're creating is going to be a table. And here we're calling a table, it's like a sheet in a spreadsheet, and we name the columns and what type of columns that they're going to be for our table within the parentheses here. The system that is implemented in the sandbox and the one that we're going to be playing with is one called SQLite 3. All right, so SQLite is a relational database program. Now, a lot of databases function in a client and server kind of way, and it requires that you run a server that serves up the database itself to a client, and then, you know, usually the programmer or a program is working through some client to query the data and do stuff with it. SQLite's a little bit different because it will operate locally with just a file, so it doesn't need the server software running. And it's really useful because you can just invoke it from the command line. But all other aspects, all the syntax, almost without variation, are exactly equal to every implementation of SQL. So SQLite is very convenient for our purposes in that it's exactly like using one of the full-fat regular databases, with the exception that it's much easier for us to start using without installing stuff on our computer. So that's why we're using SQLite. And the way that we might do it is, and you know, you should practice this following along with the tutorial, is you first invoke the SQLite 3 command to let the system know that, oh, I'm going to spin up SQLite 3, and if you do this and you specify the name of a database with the .db ending, then it's going to create that database for you. And, it'll ask you a confirmation. Are you sure you want to create this? And if you hit yes, what it does is it starts up SQLite, and you'll get a new prompt that represents the fact that you're you're actually opening up and using from the terminal SQLite then. And you can alter various aspects of the behavior. You can start up a mode, and there are different modes for different file types, but you can set the mode to CSV. And ultimately what we're going to do is we're going to import a file, and then to quit, you have to use the quit command. Notice that a lot of the commands, the keyword commands, are starting with the period syntax, so keep that in mind, especially quitting off the terminal. So if you have a CSV called favorites, again, you're just going to follow along with the notes. You can import it with the import command, and import specifying the file, and then name the table that you wish to be added. All right. And then finally, once you've done the work you want to do, you end a session with the .quit command. All right. So databases are arranged like, we can think of them like different tabs in a spreadsheet file, like an Excel file, and each of those tabs represents a table, right? Well, the relational part and the data structures contained within each of those tables is represented by the schema. Okay, so you can visualize the schema with the schema command. At the command line, it simply lists the names of the table and the names of the data variables that are contained within that table. And if you if we then use our first real SQL command, and again, I'm just talking through what the notes will guide you to do to do yourself. If we use the select command, the structure of a select command is select, naming which columns we want, and then the from command to indicate which table we want. Also notice that the syntax is different than Python, as we're back to semicolons at the end of lines. Okay, so if you execute the select star, the asterisk represents a wildcard to select all the columns. From which table? The table we have is favorites. And you should get something like this. It should be a long list. I can't remember, maybe there are 50 rows in this favorites file. Right, so well, we can summarize the data to wrap our head around it. My way of calling the trying to understand a data set is to weigh the pig. And there are lots of useful commands to weigh the pig in SQL, that's for sure. All right, so we can select some data, and we can count how much data we have in the whole structure from favorites. And it just gives us a little table summary of how many data points we have. It's not 50, it's 313. And this is a data set of a survey of which languages students like and which assignment they prefer. And, if you want to look at which languages they want, you can select distinct language from favorites. So it's some keywords, select and distinct. So distinct will, if you have a variable that you're specifying, in this case it's language is the variable, distinct will tell you the unique values within that variable from some table. Okay, so what you see when you execute this command is that we have 3 distinct values, and the values are Python, C, and Scratch. Now, there are lots of ways to manipulate all sorts of variables that we have. In this case, it's a categorical variable with some strings in it, and the string values are limited to just these 3 values, which is just quite nice. But we can combine select with things like count and distinct to create different summaries, and it's very powerful and very fast. Notice how we can do that with just the 1 line of code. And for example, up here, we can select the count from favorites where the language equals to C, which we specified in quotes for the string capital C, and we can count how many we have, 59. All right, so so what's happening here is we've got this vector of values. It's visualized here like it would be in a spreadsheet with a header row, the first row that contains the name of the variable, and we could select language in this case to grab this row and do something with it. And here things we've talked through, the code we've talked through identifies C and the Python values and the SQL values, and we can group these from a table that looks like this with a command like this. So we select language, count everything from favorites, and we group it by language. And here we've got the counts in a count column. So we've returned an extra data summary. And here are some commands for you to try that result in some slightly different outputs. For example, we can use on the real table the same exact command that I just showed, except this time it's got the 313 values, and it lists them like this. And what you can see here, what about the order of these variables? We haven't ordered it at all. It looks like it's ordered it alphabetically by the value in the language column, which is fine if that's what you want. But maybe you prefer some order that's different. So we could order it by the count, in which case we've ordered it by count from lowest to highest. No, we didn't tell it to order it lowest to highest, but with the descending qualifier, we can resort it from highest to lowest, descending value. All right, so you get a feel for these. The nice thing about SQL is that there aren't a huge number of commands. The biggest thing about SQL is to learn the design patterns to do things that you do all the time. And I find SQL to be very repetitive, almost comfortingly repetitive. And if you have a small cheat sheet of things that you do commonly, commands that you use commonly, and design patterns that you use commonly, it will take you very far in the SQL world. So there's a whole bunch of examples in the notes that do things like group by, limit to limit the number of rows that are returned, order by to order by in either numeric or alphabetical string columns, a where clause that sets a Boolean. And so you can think of these like building blocks that we use. What are we building? Well, we're building queries, we call it. And the queries are commands that allow us to do powerful work with data. That's the whole story with SQL. So we talked about inserting data. Now, this is how you add data to an existing table. So we use the keywords insert into, we name the table and the column, and then we provide the values. Okay. So maybe we've got something like our a database like this. Maybe there's a timestamp column and a language and a string column for the your favorite assignment. And then maybe down at the bottom, another value was inserted, but it lacked the timestamp because it didn't come from a computer system. We manually inserted it. Well, this is where the null value might be used. And unlike null in other languages, in other data structures, in other languages we talked about so far, where null values the absence of a data object is kind of a default for when there just isn't any data. In SQL, it's a bit different. In SQL, the null is explicitly named when there's the absence of data. So it's a subtle difference. It's a conceptual difference, but it's an important one in the SQL world. Likewise, if we didn't like that row that was added in the previous column, we could delete from the table favorites where timestamp is null. So the Boolean expression that the where indicates. And you can see down at the bottom, this is the same data table, but the null value is gone where the null was in the timestamp column. So likewise, we can update a table, and in doing so, we use the set command, where column is equal being the assignment operator to some value where some Boolean condition is met. Okay, so all of this, you need to look at the notes and go over that and become comfortable with it. All right. So what if we had a database from the Internet Movie Database, IMDb? I hope most of you know about that. It's a pretty fun website. It's got a huge database on all sorts of movies and television shows. This is one from the American Office that's shown. And what we can see is a number of tables. So maybe we have a table up here like one that's got the title of the show and then a column for every star that might be in the show. Now, this is a bit awkward. One reason it's awkward is if we're thinking of a data set, we've got these header values that are all the same. And so immediately, if we're thinking of tidy data, I don't know if you've encountered that concept yet, where each row is unique and independent of the others. Maybe we would rearrange this to something like this to make it tidier, where we have just the title and then a column for stars with different values. Now, this is a bit repetitive because we've just repeated the office over and over, and yet this is a very common way to store data like this. Now, we could go a step further. We could go a step further and replace these strings with ID numbers. There are reasons to do that, to do with the efficiency of searching and indexing things. But we still have that redundancy over here. But each person has a unique ID, And if there were other shows, each show would also have a unique ID. And an interesting thing that we could do that would reduce some of the redundancy would be that if maybe we had a table that was just shows that listed the ID, index, and then the label for it, and another table that was people with individual IDs and the table for it. And then finally, you could put these two databases here, these two tables together in yet another table that recreated this fully indexed table. Now, this on its own is, you might be thinking, God, that's not too useful because I'd have to go over here to find the person, and I'd have to go over here to find the show. And for humans, that's true. But in the relational database world, this is just how things work. And it's what makes them so fast for massive databases like the IMDb database. Now, the database file, the flat database file, it's actually not a flat file. This is the schema that I'm showing you for the database that you have access to. And there are hundreds of thousands of records in there. And these are the names of the tables that are in there. And you're going to work through the notes and do some operations on this table as time goes on. Well, one of the tables is people that have an ID number for them, the name of the person, and the birthday. And one is the show that has an ID number for the show. Now, note that this variable is called the same thing, but this is the show ID and this is the people ID. So keep that in mind in case it's confusing. They're actually not the same data. And then that's reflected, the fact that they're not the same ID. If we look over at this one, which are genres. And so here we refer to the show ID, which is the same as the ID here in the shows table, with a list of genres. And some shows will be associated with multiple genre and so forth. Okay, so we can go on and on through the whole schema to understand it. If we look at just two of the tables in the whole schema, what we might do is we could look at the ratings table, and we could select everything from ratings with a limit to 10 rows returned. And so what this would grab is just the first 10. And there's so many. You can try it yourself and see how long it takes just to print off the whole database. But this would be like the first 10. So this is how we use a database like this with multiple tables, and it's mandatory essentially to understand the schema to be able to start to explore it and to weigh the pig. All right, so there are a couple of things you can do. You can select count asterisk from shows to see how many rows there are in it, 234,000 plus. And we can select, that's the count, and we can select everything from shows limiting to 10. And we could see some of the shows, TV shows that are included in here. I didn't say it was all just the popular ones. It's all of the shows that are in the database, and there are a massive number of them. I don't know when the database starts, but I suspect it starts in 1970. It's biased towards American shows, but I think there are some British shows in there too. Now, there are different kinds of relationships that these databases have, and it helps to kind of think of these relationships when you're working with the data. So one of the relationships is one-to-one, and an example of a one-to-one relationship are the data from shows and show IDs, and we can kind of see that the arrow connects this to the two different IDs. And so this is a one-to-one relationship between these two tables based on that key variable ID. And here again are some examples to demonstrate that one-to-one relationship, which I'll leave for you to run. Okay, we're going to talk about data types. Many of these we've just encountered before. Integers are just regular old integers. Numerics are floats. Real numbers. Now, numeric is a special data type, actually, not a float. A real number is a float. Misspoke. Numeric is a special data type that is numeric in nature, but we might not be planning to do math on it. An example would be like the year or the month number. Text data are just character strings. And then blob is a special kind of data. It might be pictures. Blob stands for binary large object. Okay, so it could be pictures or other kinds of data that don't conform to the other data types. There are also a few special commands that we have, like a Boolean for not null. And actually, for data protection reasons, a call, can't be null when you make it. And unique is, we've already looked at the unique. One functionality of unique is to pull out unique variables. This is interesting and useful for summaries, but one of the times that I find myself using it quite a lot is to catch variants of a data type that are input by user error. An example of this that I've come across so many times is some value like like it could be something real simple like male and female, where somebody adds a space at the end. And maybe it's due to input error or a systematic error. And so with unique, you can find errors a lot and inconsistencies in your data. All right, I want to introduce the concept of keys. I've already mentioned that word, didn't explain it. And a primary key is one where you have like an ID variable that's unique for different dimensions of your data. And a foreign key is when we take the primary key from another table and index it in a different table. Okay, so this idea of keys and foreign keys is one that we will eventually exploit, maybe even in this module, but certainly it's an important concept to be aware of. All right, so here's an example of some of the syntax at the command line, where we don't end this line with a semicolon, and this is a complex query that we wrap. So here we're selecting title from shows, where ID in, and then we have a in parentheses, so that things in parentheses are executed first. We select show ID from ratings, where the rating is greater than or equal to 6. And then finally, there's also no semicolon over here. We set the limit to 10 semicolon. And so we just get this nice little table with just the first 10 values of, highly rated TV shows, at least with a rating greater than 6. Maybe I would say greater than 7 or 7.5 to be a little bit more discriminatory, let's say. All right, the concept of joining. This is one of the most important things that you'll do with databases, joining tables by key values. And we've already talked about the different tables that have these show IDs. And, one might have the title and one might have the rating. But actually, we want, if we looked at the rating table, this doesn't really help us to have the show ID. We really want to pair the rating, whatever it is, with the actual title. And so to do that, we would need to perform a join operation on these two tables to bring title and rating together based on that key value of ID and show ID. So like I said, this is one of the most common ones here, just visually flipped the way those columns are to highlight the actual IDs. And in the notes, you'll see that we're going to select everything from shows, from the shows table, and join the ratings on the ID variable where, maybe some conditions are met, like ratings greater than or equal to 6 and limit of 10. So once we join them like that, we don't need all the keys anymore. And we've just got our ratings. So if you go through the notes, you'll demonstrate that for yourself. All right, so that was talking about a one-to-one relationship for the schema. And, we can also have a one-to-many relationship where we were talking about genre. And, one show can be associated with many genre. Okay. So to explore one-to-many relationships, we might, run some of these commands. Select genre from the genres table, where show ID equals some number. That doesn't help us very much because you have to know the internal database ID for your show. But I can't remember which one this is. I think it's Catweasel. Catweasel. But we can see that it's associated with several genres. And, we can grab the ID from the shows table for Catweasel. And then we can get the ID. And then we can, create a more user-friendly, it is a longer query, but it's more user-friendly because it exploits the title of the show we actually want. Play around with this. See if some of your shows are in there. So what we've done here is we've got these two tables. We've selected Catweasel and the rows for Catweasel in the genre table, flipped them around, joined them up based on the ID, made a table from it, even though, this is just a conceptual step to show how it might work. Drop the keys we don't need, and we end up with what we want. And we return just the genres. Okay. So back to our schema. We've talked about one-to-one, one-to-many, and then we also have many-to-many. So what if we were looking at shows? Every show has multiple stars, but also every star is in multiple shows. So we also have these many-to-many relationships. And we can select everything from shows where the title equals the office. Now, if you look in the database, we get this and you're like, what the heck? Well, it turns out there have been loads of episodes. I think the American Office, even though I love the British Office as well, the American Office was just much more popular and ran for a lot longer. And I think that it must have started in 2005 with 188 episodes. So you can check this out through the notes. There are many queries for you to mess around with that explore that. Okay, so one of the real useful things that you're going to do with the database, and I find this just completely interesting, is the use of indexes. And what you'll do is you'll use the timer command and set it to on. And then when you run a query, what you'll get is an account of the runtime for your query. And we can kind of see that this took 43 milliseconds. That's a very short period of time. But this database file that we have is it's large in one sense, that it's like 50 megabytes. It's not an insignificantly small file. It's large, but it's, in the scheme of all data these days, in the scheme of databases these days, think of things you use on the web, think of things like Google, and think of, Instagram, and, Facebook, and Discord. These are massive databases that we're talking about. And if you have, for a relatively small database, it's taken some proportion of a second with a relatively tiny database. Imagine the scenario if the database was hundreds, thousands, even millions of times bigger. So the search time for a query would be much longer. And then imagine that there may be tens, hundreds, thousands, even hundreds of thousands, even millions of people, depending on, exactly what events are happening in the world, that are querying a database all at the same time. And when you shave off a few milliseconds, when you've got massive databases and many, many users, it's a big deal. Okay, so indexes are going to address this. We turn on the timer as a tool. You're going to practice some commands like the one shown in this picture, and you're going to evaluate the time. Indexes allow us to massively increase the efficiency of queries, but we have to think about them and use them. So the way we use them is we create an index that we name, and we create it on a particular table and even a particular column. And so we would do this if we know there are going to be some queries on a database that's of significant size, and maybe we would do this on a database that we know a lot of users may use, and it'll be a very common query to make. So this just carries on up here. This is the last thing I showed you on the previous slide. But if we create an index that we call title underscore index on shows for the column title, just to create the index takes a half a second. That sucks. It takes a little while to create an index. So one thing I want to say before I go on is that if we're going to create an index, we have to have a good reason. We're going to use it to claw back the efficiency. So it took around 10 times the amount of time just to create the index. So it's not something we would create if we were only going to use it once. But if we run that command again, and we look at the time, wow, it cuts the time down by 43 times to 1 millisecond or less. I think 1 millisecond is the lowest that it can measure. So indexes are a big deal, a really big deal. How do they work? Well, they work with this. We're just going to really brush past this. There is a little more detail in the notes if you're interested in getting into this, and maybe we'll address this in a future module. But they work on the principle of B trees. And it's a little bit like that binary search trick where we divide and conquer, where conceptually we can look at a B tree, and we've taken a big problem and we've bifurcated the problem into smaller parts, and then we've taken that smaller problem and bifurcated it into yet smaller parts. And this is sort of the way that B trees are structured. Now, there are some examples, and you can read about that in the notes. I'm not going to go into more detail here. All right, brace yourselves because I'm about to talk about the most interesting and exciting thing with the use of SQL that we're going to talk about in this module, in my opinion. And that's the use of SQL inside Python itself. So in the CS50 module, you can import SQL. So from CS50 import SQL, and you can read about it in the documentation for the CS50 library here, and I do recommend that you do that. And we're going to practice in the notes some of the SQL functionality with a concept, something that we call race conditions. I hinted, even though I didn't say the word before, I talked about millions of people doing something all at once, you know, and this creates race conditions, so-called, for a database where people are querying and updating data in a database, changing it, reading it, doing stuff with it all at once. And it sort of creates it's a similar to a race for access to the database. Okay. So you have something in social media that people go incredibly crazy for. It's going to create race conditions. This was from Instagram last year. And and basically the database down here for Insta was recording comments and likes. 75 million likes. I think this was the most liked post in the history of Instagram last year, of all time. Maybe it's still not the king now. I'm not sure, but the idea for this is that there was a lot of access to the database. Well, what if there are virtually infinite, almost simultaneous transactions that are going to happen? And for every like, we have to do something where we're updating the database to record those likes. This creates a big problem. Okay, it's race conditions. So there's this concept of transactions where we begin a transaction and then commit the change to the transaction. And we can exploit this command rollback as well. And this is a little bit what the notes will go through to test this. This is an important concept for you to understand at the conceptual level. Okay, so this is getting into some advanced territory that goes beyond what we can cover in the module. It's an important concept to be aware of. A topic, I can't remember if this is the final topic we're going to address today, but it's a fun one. It's kind of fun, and it's very interesting, and it's very important with regard to SQL. And it's a type of hacking activity that can be very illegal. It also is ingenious. It exploits the technology that in the CRUD process that SQL uses, and it's collectively referred to as injection attacks, SQL injection attacks. And the idea for this exploits syntax that might look like this. So let's say that you've got some kind of situation where you've got some rows, and you've got a database function, and you're selecting from, say, a particular user, and you set a Boolean where the username equals something like a wildcard, and the password equals something like a wildcard, targeting the username and password fields, right? So the key part of this is this expression like this, where we've got, notice that we've passed with a Python command a string that passes the SQL command. Now this is the whole basis of how SQL injection attacks work. And so what we're looking at here is for passing placeholder variables, like in Python, we might have something that looks like this, where we have a variable called username, which we specify in brackets, and we have a formatted string like this. And so, like maybe we have somebody's email address. What if we've appended a little bit of stuff here at the end? Well, note that there is an escape character. A thing I didn't mention before is that the escape character in SQL for a single quote is 2 quotes. So this lacks that escape character. And what happens is that we can pass this string query to the database, and it even though the structure of the program, the Python code that actually passes the information, requires the username and password, we've exploited the system with this injection of a false part. And this is the bad part that gets passed, whereas this is the whole part. Well, you could use the escape character like this, in which case it nullifies this attack. But what happens is it drops the part that requires the password and lets you do devious stuff. Now, there are all sorts of instances of injection attacks. This is a real common attack, and for simple databases, simple attacks will work. But there's an arms race between people who do this kind of thing for fun and for profit, and normal folks. But there's also a tradition of using this for clever, naughty ways. For example, here's one. Let's just zoom in on that. Here's one for a license plate that the registration tag is covered by this text. And what this is meant is to thwart automated detection cameras. And it passes part of a query, and it has this command, drop database table ICE. And it has this little bit of an injection at the end over here. And this is like a super ingenious, actually quite funny way to use this. It's naughty. It's civil disobedience. And of course, I would never condone anything like this. But exploiting the technology like this, being aware of potential exploits like this, is part of being good at what you do. And that's why I've brought it up. And there is a cartoon, one of my very favorite web cartoons that I mentioned before, called XKCD, that's about this. And I'll just let you read this yourself. Well, I hope after that explanation of injection attacks that you've got this. And if you talk to anybody who does any SQL work and you mention the name Bobby Tables, they're going to know about this cartoon because it's famous and and everyone knows about it. That's the last slide, and that's all I have to say about that. See you next time.